Hello everyone. I am Shinkai Gao, and our team members are all from Tencent U2 Lab. It is greatly honored to represent our research here. Titles: Coarse-to-Fine, Learning Compact Discriminative Representation for Single-Stage Image Retrieval. Our presentation includes the following four aspects. First, we briefly introduce the image retrieval task, which aims to efficiently retrieval images similar to a given query from a large-scale database. There are some challenges in this setting. To better trade off retrieval efficiency and accuracy, some approaches fuse global and local feature to perform single-stage image retrieval. However, they are still challenging due to various situations to tackle, example, background, occlusion and viewpoint. In addition, only image labels are given as supervision. There is no supervision for local features. The figure displays that more than 20% of the images are far away from their class centers, and some true positives lingering at the classification boundary receive weaker supervision in large-scale landmark dataset. Therefore, we introduce the proposed Coarse-to-Fine framework to learn compact discriminative representation. We obtain the global descriptors via a CNN backbone. Then we use Modicos alone to train global features for the first epochs, and select the attention regions as constraints to construct triplets for local descriptors matching. Finally, we train the model with both Modicos and triplet losses to infuse the global features with geometry information about discriminative local regions. In these proposed methods, we first a novel adaptive loss, namely Modicos. Due to previous works adopt arcface loss to train the model, and it makes most sample distribute on the right side of the softmax function. This leads to suboptimal performance due to weak supervisions. We automatically tunes appropriate parameters with each mini-batch by imposing strict constraints on the probability of median of cosine logits to progressively strengthen supervision throughout the training process, which keeps most samples distributing on the left side of the softmax function. We simplify the derivation of subsequent formulas, and the entire process is summarized in Algorithm 1. We then design the local descriptors matching constraints and hard negative sampling strategy to construct triplets. Obviously, we select matching local descriptors not only relying on nearest neighbor-based constraints, but also guide the networks to focus on more semantically salient regions to discard the redundant information. When we construct all eligible local descriptors of positive pairs, we introduce the triplet loss with hard negative samples to leverage fine-grained semantic relations, which embed the global feature with more information of interclass distinctiveness. The detailed sampling strategy is provided in the figure. In experimental results, we first compare the proposed method with other single-stage and two-stage state-of-the-art methods. We divide the previous methods into three groups: A. Local features aggregation and re-ranking, B. Global features followed by local features re-ranking, and C. Global features. Our CFCD belongs to the group C. It can be observed that our solution consistently outperforms existing one-stage or two-stage methods. In Table 2, we provide detailed ablation experimental results, verifying the contributions of three components to the baseline framework. When we introduce the Coarse-to-Fine framework to train the whole model with Modicos and triplet losses, and observe that it helps to improve the overall performance, especially on the hard cases. In Table 3, we ALS0 show the results of training with different anchor point in softmax function. We simply adjust rho from 0.01 to 0.05 to train the model, and the results are all significantly improved. We also provide experimental results to validate the impact of triplet loss with matching constraints, and the results are summarized in Table 4, Table 5, and Table 6. We can observe introducing the triplet loss with matching strategy to learn semantically salient region relations improves the overall performance. In addition, we also conduct qualitative analysis in Figure 2 about different methods. In contrast, more true positives can be recalled with only global features trained by our Modicos loss and triplet loss, and we obtain more robust retrieval results. Thank you for your listening.